It is go time. As you guys know, oh wow, we already got right off the start through my computer speakers. As you guys may or may not know, we are back with yet again another free support Friday with none other than yours truly, Fusion Phil over here at jitcadcam. Now, I'm going to give this a few minutes to get kicked on, make sure that everybody can get in here. As I can see, I can't see my stats. I don't know how many of you are out there, but we always got to do good old-fashioned microphone check, possibly even a audio check for those of you that are out there. Go ahead and let me know in chat, as well as anybody else out there that has any questions at any time. I just want you guys to know, feel free to throw them in chat. There's also an email down below that'll auto-generate a support ticket, and you can ask those questions live, and we can troubleshoot these problems as we go. Now, for a lot of you guys, let me go ahead and see if I can't refresh some things. I'm going to go ahead and kick this off as we always do, which is with none other than an energy drink. Now, for a lot of you out there, just so you guys know, we do have a lot of customers here at jitcadcam. They are paid customers for support that helps support this channel and makes it grow. Now, we also like to support a lot of you guys that don't necessarily have our support packages. But if you ever feel the need, you get on here, you find an answer that you didn't know existed or you needed solved. I want to go ahead and pull this up as you guys can support us by buying us beers and steaks along the way. Now, again, I'm not going to drink a beer here on stream, but as you guys can see, I do have this energy drink in front of me, and I'm going to go ahead and dive into the first problem of the day. So, what I'm going to do is I'm going to go ahead and share my screen. You guys should be able to see something here in real time. Again, I'm not seeing anybody here. Let's go ahead and make sure my stream is good. Maybe nobody's out there, right? It's the middle of the month. I did get the notification that we are on free support. There we go. The stats are coming through. I see you guys out there now. So this was a very interesting one that was just brought to me. Now, what I'm going to do is I'm actually going to model up a part here real quick for you guys. This is going to be a sub-spindle item that somebody brought up to my attention, and it was very interesting at the end of the day, the way they were thinking about doing this and the reasons why. So again, let's go ahead and just make a 1-inch shaft. Let's say it's 9 inches long. We're going to revolve that around. And just like that, we could go ahead and create our cam toolpath. So what you're going to see me do is we're going to go turning, new setup. And then with that, we have our model front, stock front, whatever you plan to work with. Now, in this case, we're going to go ahead and make our stock just a hair longer. And this actually, we're going to make it quite a bit longer to start with, as if we were running this out of a very large bar for demonstration purposes. So again, let's say we're going to go ahead and clean up about 30 thou on the front. And just like that, we're going to put nothing more than a facing toolpath on this part. So give me a sec here, guys. So again, we're going to go good old-fashioned right-handed tool. There's our facing procedure. As you can see, our stock, pretty representative of what's going on. Now, in the case of this customer's problem is they are getting these pieces of material pre-cut. And what they want to be able to do is kind of turn the whole thing. However, what they're holding on to in a second setup type of scenario, which is what I'm going to switch over to, is we're going to go secondary spindle. We're going to flip our Z. And then I always prefer to go off of model back here. So as you guys can see, working back the opposite direction, and this would actually sit about like so because we would be on the sub-spindle, is the ability to actually utilize a parting toolpath or a groove toolpath. Now, this is why I would recommend possibly the differences between the two. But as you're going to see here, is if I go up, I could actually go through and I could say turning single groove. And what I want to turn is this guy right here. So again, you're seeing me select that edge. I'm going to go ahead and say in front of that edge. Now your radii gets a little tricky, but as you guys may or may not know, we could actually set this to a inner radius or our stock, in this case, ID. And I'm going to hit OK, meaning I got to go ahead and grab my tool. So again, let's jump over to our Fusion library. We're going to go ahead and go to one of our OD grooving tools. And just like that, I have actually set up an OD grooving with a single groove profile. And the idea is we are actually going to just part this slug off so that we don't have to waste time facing a ton of extra material. So again, let's go ahead and pivot here real quick. We're going to go ahead and go back. we're going to leave a little bit of extra material on that. So we can go to our passes tab, stock to leave, I don't know, 5 thou. And just like that, we should be either in our part or out in front of our part. So let's go ahead and adjust this one more time. I believe we put in 5 thou. We did radial, perfect. However, I think that came through as axial. Let's go ahead and plug in 5 thou here and 0 here. And as you can see, I was backwards in my setup. But again, one thing to keep in mind is when we are parting this off, we are still getting a nub on our part. And that nub is coming through because of our tool nose radius, right? But again, this was just a quick way to use single groove to part off the slug in the front of our part. Now, if you wanted to do this with a parting toolpath, we're going to go ahead and do our parting toolpath here. The thing you would actually need to do is we're going to have to compensate this to the model front, not model back. And now the problem with that is going to be, is it's thinking that blue line is where our tool needs to be. And this is where you could actually utilize parameters like tool underscore groove width. And now that is going to give me the total width of my parting tool. And as you can see, it's now slid me up to be in front of my part. And again, I could actually use stock to leave here once again, 5 thou to push my tool further forward. Now in this case, we're actually going to type that in as a negative. And just like that, you can see that turning groove part off, same kind of scenario, same type of outcome, right? So again, single groove, we have turning part off, and just like that, 2 different scenarios to be able to get rid of that material. Now, for the next couple of things I am going to do here is I'm going to go ahead and I am going to adjust my stock back. Now, big rule of thumb here is if my model length is 9, I'm going to offset about 30. I would always recommend making your actual stock in your setup just a little bit longer, but not longer than basically the roll up of offset, model length, and your groove width, right? So as you guys can see, again, I'm going to go ahead and hit OK. We're going to regenerate that first tool path. Then we're going to jump down and regenerate our second grouping of tools. Let's get that activated and spun around. So as you guys can see, we are now coming in, again, still model front, plus 5 thou on the front, right? And as you guys will be able to go one step further, again, that part off kind of precision is still parting off that slug and dropping it down below. I see you guys jumping in here. I see some of the chats coming through. Guys, is there a huge delay to the system or y'all just late today? Give me a few minutes here. I do see that I got a message on my phone. But as you guys are seeing, we're going ahead and keep working here. He's here. Who's here? I don't know who is here. But again, as you guys can see, again, I'm utilizing the part off on the sub-spindle. So this is something key to keep in mind, is to go in there and actually get rid of the slug. Ah, EJ's here. Awesome. Now I know you guys aren't delayed at all. But utilizing the part off tool to get rid of that remaining little piece of slug and drop it off from what we have going on. So again, that's a neat way to do it. It's a little bit of an outside the box thinking, but when you're utilizing the sub-spindle, you don't want to waste all that time. Again, let me go ahead and go back to my original setup, fix my stock. Let's say it was 10 inches, right? Some of us are pretty legendary for this move here, but I'm going to take my facing, a little copy and paste Hollywood magic, reorder it. We're going to generate it once again. As you guys are seeing, that sub-spindle kind of situation, we would have to turn on multiple step overs. And this is just something at the end of the day makes life a lot easier. We're also going to see a reduction in our cycle time. Again, utilizing just nothing more than either single groove or utilizing your part off tool. Again, with special things with changing the parameters to get the outcome where you want it. Now, a few more things you could do here. Again, as you guys are seeing, you do have that inner radius. You do have that cut below center line type stuff. We could easily go back to when we're doing our single groove. You could, again, go to your inner radius, minus that down just a hair bit further, and actually be able to drop that lower than what was expected. Again, getting rid of that nub. So you guys let me know in chat. Is this something cool, something different, outside the box thinking for you lathe people? You could also let me know if you guys have any other questions, any other problems you suffered from this week, or if you guys want to see more about the latest update, feel free to throw it in chat. I'm going to go ahead and pivot now to a part that was sent in to me. Now, the biggest problem is I actually got a email with this part, and I got to get it pulled up here. Give me a sec. Want to make sure that I am getting you guys the latest information, but there was questions about surface finish on a part like this. Now, this is a pretty crazy toolpath to start with, which actually has quite a bit of wasted cycle time, and I think we can clean that up quite a bit. Let me get back over. I do see somebody has sent in some files. Guys, is this your guys in chat that sent in those files? Yeah, there it is, EJ. All right, give me a minute. I'll get to them here in a second. So the question at hand was kind of asking about getting a very good surface finish on a part like this. And as you can see, they've gone through and created quite a lot of toolpaths trying to achieve that task, right? Now, I don't know the necessary use case of what they're building here or what they're going for, but I would say at the end of the day is it's going to come down to what is the surface finishes need to be. Again, there's a lot of factors about this, but I do want to start off by looking at a couple of use cases. Like one, the use of the actual scallop toolpath. And what I'm going to do is I'm going to change the step over so you guys can see this a little bit better. Give it a sec to calculate. Again, what you're seeing is quite a bit of water falling as it goes around the outside of the part. So this is something that some people miss out on quite a bit, is the ability when you have a boundary overlap could be extending you outside of that area. So again, we could go ahead and set that back to 0 and see if our contact point boundary comes through and fixes our issue. Now, in this case, it did not, which would lead me to believe a couple of other things. One is a trick that I think I've showed a few weeks ago, is sometimes you need to account for tolerance when it comes down to your additional offset. So again, if we say minus 4/10, we'll go ahead and reduce that. Not quite the issue here. Again, we're still waterfalling quite a bit. I'm actually curious to see what kind of models do we have in this part, because it usually works pretty good. We got op1, we got op2, we got the master. All right, I'm not seeing too many extra things in here. So let's go ahead and take a little bit more of a peek at what's going on. So again, oh, we got a selected boundary. That is why. See, even yours truly fails to start at the top of the page and evaluate stuff like, one, it should probably be, in this case, we're going to use a selected boundary to contain our toolpath. Now, I don't know the end goal here. I think the end goal is to stay inside this window, where, in my opinion, this might be one of those things where we actually don't have a boundary at the top. We could actually go, or we will have a boundary. It'll be a silhouette. And then we'll use rest machining, but we could actually utilize different things from stock sizes, or let's go ahead and get our toolpath on this part. As you can see, we're now doing everything, but this is where the neat factors of being able to utilize something like avoid touch machining, right? So again, I could now go through here, add my avoid surfaces that I may not want to machine, taking a pretty educated guess on the case of this part on what doesn't need to be machined. And then from that, we should be trimmed down quite a bit more. So again, this is just a little different workflow. You're also now seeing the fact that something like contact point boundary is working for me. Again, reducing my water falling. We might be able to actually even remove our additional offset and still not have water falling. And then that could lead us down the path of what is going to be the better tool path for this part. So as you guys are going to see, we're going to go ahead and right click on that scallop toolpath. Now that I've got my blue lines where I want them, is I like to now jump around and take a look at a couple of different things. So again, I don't necessarily know the end goal of the wants of the surface finish here, but as you guys can see, is something as a spiral toolpath might be very beneficial. A few things about spiral you do need to know is we need to know a center point that we want to rotate around. Now, if there is a sketch in here, all telling, boom, there is a sketch in here. We could steal that sketch center point for our toolpath to go around from, right? Another couple of things a few people miss out on is there is an inner and outer limit as well to this toolpath. Usually you want to go ahead and set this outer limit quite dramatically bigger, but let's go ahead and see what that now does. So in this case, if we were going for what would be considered a clean toolpath, we are now spiraling around in our tool. So let's go ahead and get our links turned off. But as you can see, it is now starting to follow that profile a lot more, right? So again, we're looping in and around, in and around, in and around. So Crazy, I see you out there. You'd love to see my take on the latest update things you like and things you don't like. Oh, easy enough. We'll go ahead and visit that here after EJ's question. So as you're seeing, again, in real time, we're utilizing different toolpaths with nothing more than the derive operation. Again, this might be a really good kind of profile where I did see some geodesic stuff. Now, if we go geodesic, you do have the ability to actually go through and do something like a blend strategy. You could actually do a circle at center as well. And as you guys will see is with that, we need to give this drive surfaces. So again, the real problem I think with geodesic is going to be more around the fact that this part profile kind of is an infinity loop, if I'm thinking correctly. So again, we could go to that silhouette boundary, tool center, tool contact point, pretty standard stuff as you guys could imagine. And let's see what we get this time around. In the meantime, EJ, let's go ahead and get your files downloaded. I know you sent them over with the download links. It's for some reason, you guys tell me, does your open in Fusion work on your guys' end or is it just me? So again, we're going to go ahead and download this. And then we got to grab that other one. I don't know how long this is going to take. Give her a few more minutes. I'm on my other screen, guys. Just let me get these two going. And just like that, my phone has started to vibrate, which leads me to believe that those emails are already in. So let's go ahead and see if we can get those pulled. How's everybody's week been otherwise? All right, those are downloading. I'm back. Hybrid machining, great to see you out there. So again, we got a failed toolpath. So with that geodesic, maybe we go ahead. Again, drive surface in this case was pulling the entire model. So again, we could go with a scallop strategy possibly. Again, circle at center. Let's go ahead and see what we get from that. Got somebody from Germany. Love to hear it. Love to see it. So we're going to upload those again. Jumping over to the other side. Get that all uploaded. Outside of that, any other questions from anybody while we go ahead and continue working at this? Now using top solid. Nice. There we go. We do have a scallop strategy. Keep in mind, guys, that scallop strategy is being generated from a center point and it's circle at center. But right now it's thinking circle at center of the entire profile, right? So again, this is one of those games that you're really going to have to go through and say, you know, selection and silhouette. This is where I could use one of these circles that was defined. Let's go ahead and give that another go. And which one are we working with? I see 2 bracket scans. Did you happen to send this twice over? Am I crazy in this case, EJ? Can I use Morph on that project? I'm happy to go back and take a look. We could definitely take a look at what Morph might be able to do. So again, we're going to go derive 3D. Now, Morph in itself, do you want Morph Spiral or are you talking, what's the other one? Normal Morph. I would need to know. Stuart with the 5 in chat. Let's go, Stuart. So again, on the normal Morph toolpath, what it's looking for is a curve selection. So I'm going to go ahead and give this 2 curves. Usually when it wants a curve selection, it always wants 2 curves. Now, again, here's a Morph toolpath following 2 curves. So again, it is looping around quite nice. Very overkill on the step downs unless you're going for something very, very nice. So EJ, step model. Okay, cool. So we're going to go ahead and jump back, get that other one opened up as well. But you could do a Morph toolpath on something like this. Now, let me get over here. Now, on a part like this, there's a lot of ifs, ands, or buts about what you should and shouldn't do. I am seeing also that, okay, continuous rest machining looks like it's working. It's just taking a minute to come through. But based on that type of information, if you're really concentrating and really trying to machine and surface something like this, my question always goes back is like, what is the end goal of the surfacing you're doing, right? So again, is I could actually, if I had a 5-axis machine, we could look at even swerfing some of these surfaces, right? So keep in mind though, is with our swerf, we got to be aware of where we start and where we finish as well. At some point, we do need to flip-flop that profile. We're dealing with this knuckle down here at the bottom that's holding on, things of that nature, right? So again, as you guys can see, this part in particular, it's really hard to say, you know, again, going back to geodesic, quite a bit going on here. We could go ahead and give this again, what you're machining. We could change that with different drive surfaces. If you guys didn't know, again, going around that part, grab a few more surfaces here. The bad news is with the infinity kind of thing, I think you're going to have to take the approach to this a little bit more step by step and maybe only surface one surface at a time. Again, somebody asked about morph. Morph does give you some good results. If I was to go in and say, you know, I want this curve and this curve. Oh, let me go ahead and hit the exit. Get my toolpath out of the way. So again, inside curve, outside curve. Maybe a selected boundary, which is going to be that surface. And now I'm using a morph toolpath just in that one little area, right? Now, one thing I would say is, as you're seeing, because the surface is changing size, with that being said, I would actually maybe go for more of a flow toolpath. So again, this is just, in my opinion, if you go down and actually look at a flow toolpath, the nice thing about a flow toolpath is it's going to do kind of like more of a fan motion, if that makes sense. So again, there's our surface. Let's go ahead and make sure our step over isn't nothing crazy. And let's see what that flow toolpath gives us. Again, a lot of different options, even the blend strategy. This is why you have these lovely little photos to make those decisions. Morph, again, as you can see, Morph is going to follow the strategies. One big secret I would tell you guys at the end of the day, and what you're seeing here now, on this end, we're probably getting a lot more step or a lot closer step overs than we are on this end. Again, I like to think that fans outwards, right? Versus that morph toolpath that is basically trying to maintain a constant step over. Now, a neat trick about this is the ability that when you're looking inside the toolpath's passes is you need to pay attention is maximum step over, meaning it will create more or less, or actually I shouldn't say more or less. It is going to reduce your step over from this number to get an even number of surfaces. Again, if we go to something like the flow strategy that I have here, same kind of strategy happens. You have a standardized step over, but it will be adjusted based on the number of step overs needed, right? So again, if we're fanning out more and more, we'll add more passes as needed. So EJ, you re-emailed it. Let me go ahead and see. Well, I did get two different files. So let me go back to, so you have this scan here, as you can see. And then I have this scan here, which to me looks almost identical. Maybe it's me. No, it's not me. It's EJ. EJ sent the wrong files. Let me go back here and take a look. EJ, where'd you send the files over at? Give me a few more minutes here. In the meantime, I might have to jump. Okay, sending them again now. Awesome. So this is actually a really good point for me to kind of talk about scan data. Now, scan data is kind of a tricky situation inside of Fusion. As you can see, everything going on in the surface right now is this really doesn't think anything is flat. What I would need to do if I was machining something like this, or if this was a casting, I would need to actually go through and use a little bit different workflow. Now, a few things you're going to have to do is start off with direct edits possibly, as well as we need to get to a point of creating basically face groups. Now, what a face group is going to do is things like holes. It will take all of these actual groups or actual surfaces or facets and group them together. So as you're seeing here, again, I could manually create those as well. We're going to go ahead and do direct edit. Go ahead. Actually, this is a solid body. So this is where we have such a great time. So you're going to have to tessellate this based on that body. Again, what this is going to do is refine everything. We'll give it a second here. Now, this is one of the things inside of Fusion where we really got to focus on computing power. Your CPU really does make a big difference. But as you could see, I don't know if you guys can see this, let me know in chat, is we really actually have a fillet at the top here versus the hole or the bore itself. Let me go ahead and grab that real quick. I'll go back. I'm assuming you sent it in on the ticket. I did not get anything yet. Let me check my normal email. EJ, I haven't got anything yet, but again, this is a pretty cool thing inside of Fusion is we're now, basically I retessellated everything. This allows me to do something like combine face groups, generate face groups, even repair non-watertight models, right? So if I wanted to, I could go through and I could say generate face groups. And now the idea behind the face groups are to create basically one entire grouping that when we go back and convert this over, it'll turn it back into a solid feature or basically a cylinder type thing. So again, we're going to go ahead and give this again. EJ, you sent it over. Hybrid machining, can you do some parallel tool? Can you use a parallel tool and force normal to the surface, 5-axis? Hybrid, do you got a particular part or feature that you want to see that on? I want to make sure that we're not missing out. There was another question up here. Take on the latest things that you like and things you don't like. Okay, we'll go ahead and jump back to that. So again, is what you're going to have to do is, as you can see now, this entire area is a face group. So if we were to ever actually go back into this part and turn it back into a solid model, that is what is going to create what is going to be your cylinder for selecting tools and features on. So again, EJ, I'm going to give that a few more minutes. I'm not seeing anything come through. I'm not getting, oh, there it is. We're going to go ahead and grab this one as now. A few moments here. Anybody else has any other questions, feel free to throw them in chat so that I can answer them in a timely manner. So that one looks way more brutal by a quick glance, EJ, but let's go ahead and give it a minute. I got to email it over and then I got to bring it back in. But again, the whole idea at the end of the day is you guys are generating face groups. Then when you go ahead and convert the model back, there's tons of content on this, guys. I don't want to beat a dead horse, but that is what you're going for, is more or less the face groups are the Bible or not Bible, I should say. It is more or less like the original kind of features of the part, right? So when you scan something, you're getting a lot of triangles and a lot of data, and that is what's breaking that up. Again, the whole idea would be is that you could reverse engineer a mesh. So let me go ahead and grab this other file here. EJ, I think you sent me the same file again. Or are they all labeled the same? Because what you're sending me is a Fusion file time and time again. So let's go ahead and open up number 3 now. Let me get my chat pulled back up. Yep. So this is more or less the original scan. So as you guys can see, this came in and this is actually a mesh itself. So as you're seeing, when it comes to actually utilizing this, we would have to go through the process of into our mesh workspace. We need to repair, which means find anywhere that isn't watertight. Let's go ahead and give this a second now. I've angered the system. It's going to take a minute to calculate. And in this case, it looks like it may already be watertight, which is going to be great. Now, again, it's a rinse and repeat. I don't know if you guys can see this. Again, you have kind of a fillet around the top of this hole. I don't know the end goal of this part. I don't know what this part is, guys, but it's still the same kind of system, generating your face groups. Again, there's a fast version. There's an accurate version. We would see a lot of processing power needed to kind of go back and refine this. Now, because there is more facets or small little triangles on the surface, we should see actually quite a bit more detail. Let me undo that because I think this is going to be me. I need to do direct edit first. So give this a second here. So again, we're going to go ahead and get back here a couple of steps. Let's go ahead and do direct edit first. And then with direct edit pulled up, again, there we go, mesh selection. That was actually the ability to go in and do all of that. See here, minimum face groups. We don't want to preview it. Maybe we can preview it. Let's take a look. Again, based on processing power here, guys. I can't stress it enough. Your boy's on a laptop, and it is one of the latest and greatest laptops, but this is where a desktop computer is going to be your best friend. So again, I'm not seeing anything populate. I think I'm going to have to dive into this part more, EJ. Go ahead, and I have that ticket open now for you. We could evaluate it more in the long scheme of things. But yeah, basically what is happening is with all that data is going back to his original part is he doesn't have any way to really machine this with clean features, right? So what I would recommend is if this is something that you are going to be doing or a lot of, is there's a lot of ways to hack the system. Now I say that because if I was to right now go in and create something like a 3-point plane. So again, we're going to go ahead and go plane through 3 points. If I know this is flat here, notice how I pulled those 3 points along my way. And then I could simply go in and create my sketch, flipped around here, make sure I'm pointed at the right hole. And then we can create whatever that feature needs to be. Again, as you guys are seeing, there is now a whole feature. If I was to extrude that, as you'll see, I'm now cutting a true feature into my part, right? So again, we're going to have to go ahead and go symmetrical so that that hole goes all the way through. Now, I would oversize that hole at first if it was me, because I can always come back and bring that hole in with a press pull. Or I could actually create a secondary sketch. Again, the idea would be is to generate simple geometry, and then from that simple geometry, go ahead and recreate those features with true position. They want $1,000 for it to be a clickable step. Well, at this point, I'm clicking the step, but I think as you're seeing in real time, as you're working with, I could get away with quite a bit. Again, just so you guys know, if you're paying attention at home, here's like a 2-cylinder move. Let's say, for example, initially I cut that out. Then I do a secondary extrude, turn that sketch back on, grab that outer profile. And just like that, I could recreate whatever is there, right? So again, it's a down and dirty way to do it. As you can see, that would give me that whole location, a machinable hole nonetheless. So give me a sec here, guys. My nose is getting a little itchy. Every time I do this stuff, my nose starts running and all kinds of crazy problems. But again, it's getting hot up here in the north, so I think everything's starting to come out. But let me know, guys. Is that something that's going to help you out at all, EJ? I mean, again, you could do the same thing up here at the top. Nothing more than like a, 3-point plane, I think, is going to be your best bet. Grab your 3 locations. Just like that, I now have something to work off of. If this was supposed to be flat, again, this is nothing more than creating a sketch. Maybe I do a circle at center point and then a secondary circle. I can now extrude that outside profile and flatten out that surface, whatever I need. Again, we'll go ahead and go 2 sides this time. Pull this one up. Pull that one down, whatever it is going to give you the flattest surface possible. And then again, you could come back with like a normal extrude back up the other way to bridge that gap back in. So I emailed you a file that I'm working on. I was trying to make the steep and shallow more efficient. Yeah, no problem. Let's go ahead and see if I can get that file pulled up. Get this downloaded. There we go. Again, for anybody out there right now that is joining, feel free to ask questions at any time. Anything in particular you want to see. I love when Jeff sends me parts. They're always crazy and wild things that make me question what I'm doing, because he is doing a lot of woodworking, and it's kind of funny the parts that you see on his end, or like weird geometry with modeling to wrap handrails and stuff. Good time nonetheless. Let me get everything bumped around here. And with that part pulled up, so EJ, I see you out there in chat. Going to have to completely remodel the thing. That's what I usually have to do. Yep. I mean, remodeling it tends to work a lot quicker if you're somebody that's more of a like a, how can I put this? More of a model kind of guy versus a surface driven guy, or like a mesh data. So again, as you guys can see, we got this part from Jeff over at Hybrid Machining. Jeff, you're going to have to give me a little bit more information. We're running through here. It looks like you got your steep and shallow here. So what you want to do is make this a lot more efficient, and you want to keep the tool constantly perpendicular to the surface, or can you give me a little bit more information? I know you said parallel to the surface. As you guys can see, if we go into multi-axis, he's already got 5-axis set up. Now, what he needs to do right off the rip is he needs to go ahead and change out to lead and lean. And the reason why you want to use lead and lean is because this is going to maintain an angle against a surface, right? So again, as you're going to see lead and lean, if I start to go down through my options, you're going to see one, this is leaning, or actually this is lead, meaning tilt the tool into the cut or tilt the tool away from the cut. Then you do have things like leaning that tool, which means left and right. Now, one thing I'll show you, you guys look a little bit further down. This is the perfect example of my big fat head being in the way. I always love that, right? So again, we're going to go to the lean section. Why it still puts the image behind me, I'm going to snap, I think. All right. Now you guys can see the image right where the chat window is, but it's something to pay attention to, because if your lead and lean angle is 0, you are going to be perpendicular to the surface. Now, in their example, they went 88 degrees, which is almost 90, which would be parallel to the surface. So by nothing more than turning on the lead and lean and hitting OK, we're going to get one, avoid model automatic mode is not allowed. So again, we're not going to be able to use collision avoidance, or we're going to have to utilize to and from curve type scenarios. But let's get it turned off to start with. Now, he does have tool axis limit on, and we're going to go ahead and trim the tool path. Now, in my opinion, I would actually machine at tilt and see what that gives us. So we'll give that a few seconds to calculate. One thing I'm also going to do is regenerate a couple more of his tool paths so we can get a stock model coming through here. It's not going to be the biggest deal, as I could see, because he's cutting these out like a window. So let me go ahead and jump back over to chat. I see you guys popping off quite a bit. See a ton of people out there. Guys, if you have questions at any time, feel free to throw them in chat. As well, we are going to cut this off at the top of the hour today. I got kids that I got to go feed and chase around the house. Again, give that a little bit longer to calculate. Now, somebody did ask the question about the latest update and some of the things that I love. And one of the absolute things that I love, take for example, this entire setup, is when you go in and simulate, and I say simulate, not simulate with machine, guys, is the ability to go ahead and hit this little simulate faster button, and then just nothing more than cranking all your settings. Now, there was a warning about this, is if you're using comparison, apparently there is a lag to the system. However, as you're going to see in real time, this thing just cooks through all of my setups. So again, is if it's something I'm looking for, I have collision detection turned on. So let's go ahead and get that turned off. But as you guys can see in real time, how fast this thing just simulates through the part, runs all the tool paths, and gets you set up for success, right? So again, big thing to me. Love to see it. Now, steep and shallow wise, as you guys can see, here's the steep and shallow toolpath. We are maintaining the tool perpendicular to the surface. So again, if I went back into simulate, we're going to go ahead and turn off the actual toolpath lines and the stock. Actually, we'll keep the toolpath on. But as you guys can see, when we're machining, we're going to start to tilt that tool as we need based on our geometry. So again, let's go ahead and look at this a little bit more from the side. Turn the speed down for the sake. Looks like we are stuck in a specific angle. So we might have to go back and do a couple more things here because, well, actually, technically that is at 30 degrees to the surface. But I'm going to do one of my favorite things, as you guys may or may not know, is let's just do a brand new toolpath so that we can get the most default values possible. 5-axis, lead and lean. We're going to go ahead and stay at 0. And with that, silhouette of our part, good old-fashioned contact point boundary. And let's see what we get this time. Now, again, I'm going to go back to his part and evaluate a few things. So it looks like we are using a model for some reason. Jeff, there's no reason to actually add a model. And we are working with setup Z. Oh, you have override tilt angle on. That's why, guys. So we go ahead and kick off override tilt angle. Now, what override tilt angle is going to do is it's going to lock the machine at a specific angle. So JC out there from Cali, hey, look at that. EJ, you got a partner in crime out there in California. So again, what I want to show you guys is if we go back now, if I'm looking at multi-axis and I do override tilt angle, it's exactly that. It is going to lock your machine at a specific angle, right? So if I wanted to on this part actually go through and machine it at 30 degrees, for example, I can force a 30-degree locked machine position, right? So again, one thing to keep in mind, you could also do this with tool orientation, but in this case, you have that ability, again, to simplify the process. Now, here we have our toolpath. We're not going down all the way, but if we went through and simulated this again, and we're going to go ahead and hit play, but we should be seeing quite a bit more tilting. But we are working on the flat area, which would mean we're going to be perpendicular to the surface. Again, running around this part, quite a bit of a step over here. And then once we get out far enough, we're going to start tilting. So we did see that a little bit. Let me go ahead and hit pause. And right there, you're noticing that we're constantly maintaining perpendicular to the surface, or 0 degrees with the lead and lean as we come around and change our angles and follow that surface. So Jeff, you're gonna have to let me know, does that look like something that's gonna work for you? A couple other pro tips I would throw in here for you guys is these are some big old flat surfaces. There would be a better advantage if he was utilizing something like flat on these surfaces. And the reason for that is if we go 3D flat, you do have multi-axis. We can say 5-axis in this case, and we can actually do a primary automatic. So again, if I wanted to go through this process, let's go ahead and grab something that's bigger and flatter, 3/4 inch flat. Again, we have all of our surfaces detected. We're going to go ahead and hit OK. Give that a few seconds to think about it. And while that's going on, let's go ahead and pull our other toolpath down. This is where I would actually now go in and do our geometry. Again, I can avoid surfaces. These two big old flat areas I don't need to machine. And this would actually make this toolpath a lot more efficient and simplified. Is there a need to rotate the machine when the tool tip is round? Yes. Pablo, if you didn't know that actually there's a lot of value in tilting a ball end mill. And the reason for that is I'm going to go ahead and switch screens here real quick. Let's get this pulled up here. I'm going to bring this tab over here in a second. Now, the issue is when utilizing something, basically any end mill, right? So with a 2-flute end mill, both flutes technically go to center. But if we start to look at something like this guy right here, I guess I should make sure that my OBS is showing you guys this, is if we look at this tool here, and you look at the very, very tip of the tool, there may only be one flute to center. So even though you have 4 flutes, when you're cutting below, let's say 5 degrees, you actually only have 1 flute as a whole. Again, here's another pretty good example, not to pick on Ken and Metals by any means, but if you guys notice, this 1 flute right here comes up to center. You may get lucky with a second flute here going to center. It does look like this. It just looks like a reflection. But then you're getting 1, 2, 3, and 4 not to center. So even though this is 6 flutes, as you guys can see, actually, this is a way better picture now. Again, we have 2 flutes to center, but we have 6 flutes total. So based on that information, we may need to change our speeds and feeds below, again, let's say 5 degrees, because it's still only a 2 flute end mill. If you've ever seen surface machining in those shallower areas, you may or may not have noticed that you'll get like what looks like smearing or tearing or imperfected surface finish. So again, something for you guys to take back, a little bit of information for you guys. Again, if we're looking at flat toolpath here, as you can see again, that 5-axis flat is going through and picking up anywhere and everywhere that is flat for us. Again, machining that. So again, we actually got these outside surfaces too, which is a little crazy. So Jeff, you'll have to let us know, is this something that would be up your alley? I think what I would do is, this is not the cleanest of beveled edges here, so swerfing this isn't ideal. But again, something like a flat strategy has worked out quite well in this particular part. You could, of course, go back, change your geometry out. As you guys know, if you guys didn't know this trick, this is another really good trick. I love this trick. Is I could actually say avoid the entire model and then only machine these 2 surfaces. As you'll see, it's a reverse system for quickly selecting areas to machine. Ed, I see you out there. So give me a second. Let me grab another drink here. I got to check the time. Like I told you guys, we're done at the top of the hour today. Ed, you need to buy a new PC for Windows 11. I think I made a video too on this subject. Yep, no problem. So, couple of things. One, I have my old laptop computer. It's a great computer. It's a 1.5 years old. It's top of the line computer that I'm looking to get rid of. That if you guys are looking for a deal on a computer, let me know. I have one. But overall, what I would recommend, and now I'm going to get some flack for this, guys, and some of you are going to know why and some of you aren't. And everybody out there says you should just build your own computer. I'm not a fan of it. And the reason I'm not a fan of it, because I use laptops. I like to move my computer. If my computer breaks, Dell has probably one of the best service plans I've ever seen. But for those of you out there, if I was looking for a computer, again, whether it be a laptop or a desktop, I always tell people, go for a gaming system. Now, you don't need, and I want to put this out there for a lot of you, depending on your budget, you guys don't need to go out and let's say we get this massive Alienware 18. And then from that, you don't need to go buy the biggest and baddest model possible. And the reason why I say that is even though they have now released GPU calculations for simulation, this graphics card right here is still kicking most machines' butts, plain and simple. Yours truly did buy this machine, full disclosure, but as you can see, is you could save a couple $100 right off the top and get something that's a little older. Now, again, if you went down to a smaller 16-inch, the price gets better. Again, the Ultra 7, and this is the newest version, versus Ultra 9s, there's not going to be a huge gain inside of Fusion. As a lot of you know, you're still stuck to processing core speed more than number of cores. But if I was somebody, again, if you're not doing anything too crazy, I tell most people you want to go out to Walmart. I have no idea what that is on Walmart's website. But if you, again, gaming laptop at Walmart, very easily, I would go ahead and roll out and see what they have in stock in your local store. And then from there, what you're going to want to do is spend basically about $1,100 to $1,200. So again, you might have to spend a little bit more depending on what you have. This is, again, equally an outstanding machine for $1,400. Now, the only thing I would recommend is this is 16 gigs of RAM is jumping up to 32 gigs. It would be something I would do if you're one of those people that don't know how to close out tabs. So As you guys can see, again, you don't have to spend a ton of money. You could always go to a lower price than this. In the case of my Walmart local to me, there's not really a crazy less price. Again, a $500 computer gets you a $500 result. I want you guys to know that. Just if you're out in the market to buy a computer, I always tell people, keep it between $1,000 and $1,500. Expect to replace it in a year, right? So again, we could go to Dell. We could say desktop, gaming desktop computer. You don't need to spend $2,800, guys. This $1,200 computer, again, great steal of a deal to be able to do what it is most of you need to do, and even starting to dive into multi-access. And my ruling is still the same. Spend a couple of dollars. Let me get back over here and upgrade it to 32 gigs. You'll be extremely happy. I promise. Awesome. Any other questions outside that? Let me go ahead and jump back over. Ed, I hope that actually answers your question. Pablo's not going to buy a computer for Windows 11. I get it, man. Understandable. Trust me, I beg Autodesk all the time. Why can't we have Linux? There's a lot of security reasons. There's like 4,000 different Linux operating systems now. I'm a big fan. If we could put Fusion on Steam OS, I'd be done with Windows 2, man. Hybrid machining back edit, that worked for me. I did one with the flat strategy and it worked well, and the lead and lean button is what I was missing. Yep, no problem. Glad to be here for you guys. Again, as you guys know, we're here almost every Friday unless I'm out of town training somebody. But thank you. You have a laptop, but my PC is not Windows 11 compatible. Yeah, Ed, it's a rough thing. I know a lot of people are struggling with that whole Windows 11 jump. Now, keep in mind, guys, I've been on Windows 11 for what feels like 2 years now. You guys can move the icons over to the left, make it feel like Windows 10. You're not missing out on much. I promise you. The leap up to Windows 11 is not that bad. It's only bad if you have an older computer that can't do it or is struggling. Steam upvote from Ed. Awesome. Glad to hear it. So I'm going to go ahead and jump back over, guys. Do you guys have any other questions? Seeing emails come through that are not pertaining to good old-fashioned free support Friday. Get the desk pulled back up. That one is good. That one is good. Cool. I'm going to open this up. What is the specs on my laptop? So, Neil, the exact laptop that I actually have is the... Let me go ahead and pull it up here. And again, this is going to be my honest opinion to you guys. Is I bought one, I had some very specific things that I wanted. Keep in mind, guys, I'm flying quite a bit. So I went with an 18-inch. And the reason why I like the 18-inch, it's just a bigger screen. If I was on a shop floor, by all means, guys, I'd be on a 16-inch. But I went 18-inch, and then I actually bought this computer right here. Again, I think I got a better deal than this. It was on sale for a little bit. But overall, I'm streaming stuff. I'm editing videos. I'm, doing a lot of heavy 5-axis training from time to time. You do not need to spend $3,000. I do not want to say this enough to you guys. Don't go spend $3,000 on a computer. $2,500, this thing is going to do plenty for you guys if you're in this market, right? Again, if you go down to the 16-inch, you could get into a cheaper computer. Again, $1,800, I would still say that almost is too much at the end of the day to spend on a computer that you're probably going to replace in a year. I would even tell you guys this would be my take on it. Computers are a consumable like end mills, drill bits, and taps. They're at that point where the market moves so fast and so many things happen. I would even tell most of you at the end of the day is, again, this is just me, is if you can get a 2-in-1, which, what is it? Asus makes probably one of the best 2-in-1s out there. Again, this is where I would stick my money into if I had to go out on the shop floor a bunch, make a bunch of changes in real time. Again, there's a lot of really neat things out there that people miss out on. And if you went with the desktop, you can do something like Chrome Remote Desktop. This allows you to actually access a desktop computer. Again, very easy to remote into a bigger, more powerful tower from something like a tablet or a crappy laptop. This would actually be probably my #1 recommendation for most of you out there that need to go to Windows 11, but still have a very good Windows 10 machine, is you could easily, again, buy something like a gaming desktop tower, save yourself a ton of money, and then just remote into it from your laptop, right? Again, you go out, spend a couple $1,000, not a couple $1,000. What am I talking about? Again, you go out, you could pick up something like this, save your money, keep your old computer, use your old computer for email and everything locally, and then just jump over to that desktop whenever you need to go ahead and do all of your Fusion stuff, right? Again, very valuable option. I'm going to go ahead and turn this back over to you guys. Any other questions out there from anybody? I did see there was a question earlier about the update. Now, if you guys didn't know, last Wednesday, we did a workflow Wednesday where we started to dive in to the different things about Fusion and the latest updates. And I will say, on my side of things, I don't think there was anything. No, technically there was one thing I didn't like, but in the event, if you guys saw it, is when you're creating tools. Go ahead and give this a second here. So let's say we're going to create a brand new tool and we're going to make a, not a slot mill. What am I doing? Oh, wow. We went back to square one. Give it a sec here. So if you're going to go in and you're going to make a thread mill, right? Or a turning thread tool, the ability to go in and now define more about that tool is nice. I think it's still a little light on what you can and cannot do here. For example, again, you could have a flat, you could change your angles. Like, I think it would be nice, and this is me, that if I could pick this based on standard thread sizing to determine standard thread profiles, right? So for those of you that don't know what I'm really talking about, is if I go back to design, let's say, for example, we go ahead and get all this stuff turned off. There we go. Let's say, for example, I had to actually do something like a, in this case, we want, what is it? Like pipe threads, or, there's a lot of different specialty threads. I don't know what it is off the top of my head. What is it? Like a tapered threads. They're pipe threads. I know they're pipe threads, but there is one in particular that is like a specific pain in the ass type of tapered thread. MPT. There it is, right? So when I'm doing MPT here, right, like there should be a thread tool profile for MPT. That's all I'm saying, right? I think what they're doing is great. I think it's just early in the stage that we haven't seen the full implementation. That's probably the only thing that I saw that's a little crazy. Now, I know for some people out there, they didn't really understand the trace tool path. And here's a little better idea of this is when they do the trace path here for a lathe, they actually show it later in the video, but they're using the edges. And this is what I was kind of talking about in my Wednesday video, is this is a face groove in this particular use case with undercutting, right? And there's not really been a good way to create a finished profile to do something like this. And this is a big deal if you're starting to get into niche and different types of workflows, right? So again, is that ability to actually go in and create that sketch profile and then not only define which direction you want to go, but also, do you want to do the whole thing? Again, multiple passes. This is something I think is huge in the right application, right? So again, as you're seeing, they're feeding at that angle of undercut. Now, I'll be the first one to argue it with anybody. Yes, the ability of what these tool profiles are, and the tools need to be able to accommodate much more customization. That's a whole nother conversation, right? So again, here, you're going to see it, guys. They're going to go ahead and go in. They're going to use a full loop now. If I remember correctly, you could now feed down and around, or I think you could do only up, only down type machining. So again, there you go. Just something that I saw. There's in, over, back out, and then back the other way. Looks like they're making multiple passes. Again, open chain, closed chain. So how can you drive an MPT thread mill single flute? That's a pretty good question. Now, The way I would show you, and some of you are going to have to help me out there, but let's say, for example, I just have nothing more than a block, and that block has a hole in the middle of it. Now, if I needed to do a MPT thread of some sort, what I need to do is I need to taper the surface. Easiest way to taper a surface, simply go in and do what's called draft. Pick the surface you want to stay flat, pick the surface you want to add some angle to, and now if I wanted to put 5 degrees of taper, and I don't know how well you guys can see this, we'll exaggerate it a little bit. As you can see, there's now the tornado effect. But just like that, now we have a 5-degree tapered hole. And when I do my thread milling, again, back to manufacturer, again, I do have videos on this, guys. You guys can search my YouTube channel, like it, leave a comment, let me know that you watched it so that I don't have to sit here questioning. But if I was to go in, again, 2D thread, that's going to be my surface for threading. I'm going to have to pull a thread mill. I don't think there's a thread mill in the standard library, is there? Oh, there is. Okay, so there's a single point threading tool. As you can see, it is now following my surface straight down to create that. The idea would be is your surface here would actually be either your major or your minor. Again, we could go ahead and do our offsets, everything and anything as normal, right? So now, JC, if you're referring to a lathe toolpath, it's the same kind of outcome, right? So again, create my sketch. Here's that guy. Let's say we do OD here, right? So it looks something like this. Again, because I have a tapered surface, I'm going to go ahead and revolve that. Round center. Now I go back to manufacture, create my new setup. Go ahead and select my Z-axis. Actually, if we would have just selected turning, it would have been automatic. And again, turning, thread. What do you want to thread? I want to thread this surface here that's tapered. Need to grab a thread mill, or not a thread tool, a threading tool, OD threading. And now you're going to see is that tool path is starting down here and it's working its way up, over, and around. So again, based on doing MPT threads, as long as you're defining a tapered surface to match that thread, it will automatically pull through at the end of the day. So guys, we are at the top of the hour. I'm going to give you the last chance to ask questions if anybody has any out there. I also want to hit you guys real quick with the fact that we are kicking around the idea of doing some new content. Now, I've heard this asked a bunch about people wanting to register to do an online Fusion bootcamp. Usually this is a 3-day class, which is CAD for CAM on day 1 to basic 2.5-axis milling into 2-axis lathe. Now, if you guys want to see stuff like this, leave comments on our video letting us know. Go ahead and send us an email with that info email address down below. I've come up with a few other ideas, maybe a modeling Monday where I just design random crap. You guys send me napkin sketches and we try to fix them. I don't know. What is it in the market that you guys are for? Do you want to see more free support throughout the week? I've also started what I would call is the Stump the Chump, where you guys can submit parts and we can compare what you do versus what I do. And maybe I program them blind and then we pull your part up and take a look. But go ahead, let us know. I don't know what you guys want. We have the ability to do an entire guided courseware as well through our support portal. But also, guys, if you found something new, had some questions answered, you're not a current support provider, current support receiver, feel free, buy us a beer, buy us a steak. Let us know that you like the content through likes, subscribes, and also sharing our content to the other people out there. So, no more questions. That's it. We're cutting it off. Guys, have a great, outstanding rest of your Friday. Hopefully you're already off work. Get out there, drink the beers like I'm going to do all weekend. And as always, it's not what you know, it's who you know. And you all know Fusion Phil over here at jitcadcam. Have a good one.